So I2E stands for Interactive Information Extraction. And many of you may have come across Linguamatics before. We're based in Cambridge, UK. We also have a Boston office. We're about 80 people now. And really our software is able to perform real-time natural language processing, that's NLP-based text mining, in a very agile, flexible, interactive way, with the core aim in mind to not only extract facts and relationships, but to build those relationships into a knowledge base to allow you to form both direct and indirect knowledge and synthesize new understandings. So we work with pharma and biotech, in this case 17 out of the top 20 major pharmaceutical companies, and also in the healthcare and government sectors. So today, what I would like just to touch upon is the kind of ranges of different tools that we use when we perform text mining using I2E. And we've got our ability to recognize terminologies, so these are ontologies, specialist vocabularies, and we can make use of integrating publicly available thesauri into our technology and layering that over a level of natural language process, so we can distinguish the difference between pressure but not blood pressure, perhaps. We can do that in the context of regular expressions, and of course we can do that at high throughput. But what I wanted to spend most of my time on is talking about the chemical searching and chemical capabilities that, making use of ChemAxon technology, we've been able to include within the I2E software. So what do we mean by semantics? So it's straightforward to identify entities, in this case a drug, and also recognize that this drug is related to a gene, COX-2. But what is actually we're interested in most cases is understanding the relationship between these two entities, and the fact that that this is a drug that is a selective inhibitor, and we can do that straight from the text. Now we can do this in a whole range of different content. The content that we can cover is really at the is up to the user, but we can take internal content. So that might be PDF, Word documents, PowerPoint, XML. We can take content from the on-demand service that I2E also offers. We can take publisher content as well, and also content coming from perhaps a third party. And we can do this in a consistent, federated text mining. We believe we are the only truly federated text mining technology currently available to the user. And what this example shows is that you're able to effectively, in a single query, ask questions around, say, a hormone and a relationship to a different disease type across different sources of content, and allowing the user to do a fast review of their data. When it comes to chemistry, we've integrated ChemAxon's name to structure technology to identify chemicals and chemical concepts in the free text of the document. So we can recognize chemical names and give a smiles or an inchy string. And having recognized those chemical names and associated that with a structure, we can then go full circle and allow clustering of the chemicals with the same structure to show off different properties by assigning a consistent name. So how would somebody in I2E go about searching chemistry? Well, you can make use of Marvin Sketch to draw a structure. You can then have the choice of performing a substructure or similarity search. You can apply this then to a filter, and this will be typically done in a context of finding out other information. And then you can output the systematic names or the smile string. And of course, you can do this at scale. So the next couple of slides show examples of how that can be used, specifically in structure-activity relationship extraction, in this case from patents. So it's possible to combine information from different parts of the patent, along with a definition of a compound in in the description, and somewhere else there may be a table with important potency information, and then that typically would be trapped in free text and require significant manual work to actually extract that. So in this, my final slide, we can see that actually by defining a query in I2E, you can actually extract the chemical name, associate it with an example number, and then in a table, bring back this structured information. So here, we're able to recognize that this table contains information around the inhibition metric and extract its value. And then associate not only the chemical name, but also its structure. So, well, thank you for listening to a very hoarse presentation. And if you're at all interested in the aspects that I've covered, come and visit me at the booth, and there's more information at our website. So thank you very much.